Hi, my name is Mr. Rupp, and this is Algebra, section 11-7, and we're studying rational expressions with unlike denominators. Last week we did with like denominators, and this week we're dealing with unlike denominators, okay? So again, just like last week, this week, all of these are just fractions. They're just a lot more complicated than what you're used to seeing. But they still follow the same rules. You can't add fractions with unlike denominators. You have to do something to get them to have a common denominator, okay? So that's what we're going to practice today. The first concept that we're going to go over here is the concept of the least common multiple, okay? Now get that in your head. Least common multiple. A multiple is something bigger than the original number. So 2, 4, 6, 8, 10, those are all multiples of 2. Alright? The least common multiple is the least number, the lowest number, that is a multiple of 2 or more numbers. Okay? It doesn't have to be just 2, it can be 3 or 4, but I think in this section we're just going to be limited to 2. 2 is bad enough. Alright? So let's work with that for a minute and work out some of these examples, okay? So we're going to do example 1 here. On page 614. Okay, so this is on page 614. And it says find the least common multiple of between 15m squared b to the third and 18m b squared. The first thing you have to do is you have to break these down into prime factors, okay? So 15m squared b cubed. Breaking that down into prime factors, we have a 3 times a 5 times an m times an m for the m squared, and then times a b times a b times a b for the b cubed. Alrighty. For the 18 mb squared, okay, we have a 2 times a 3 times a 3 times an m times a b and a b. Okay, so these are the prime factors of each of these expressions. Okay, now to find the least common multiple, all right, you use each prime factor that's common here, the greatest number of times that it appears in any of these factorizations. Okay, so what does that mean? So the least common multiple, the LCM, we go here and we look. Here's a 3, all right? There's 1 3 in the top, 2 3 in the bottom. So we use, well, actually, let's start with the lowest numerical. Okay, here's a 2. There's no 2 in the top, but there's 1 in the bottom. So we have at least 1 2, okay? We look now at 3s. We have 1 3 in the top, but we have 2 in the bottom. So now we have 2 3s. Okay, we look, the next one we have is a 5. We have 1 in the top, none in the bottom, but we have at least 1. So we join him up. Now we look at m. There's 1 in the bottom, 2 in the top, so now we have 2 of the m. And finally, the b's. We have 2 on the bottom, 3 on the top, so we have 3 b's. Okay, putting this all together, 2 times 3 is 6, and 3 times 5 is 15. 6 times 15, 90. Okay, so we have 90 m. We have 2 m's, so that's m squared, and we have 3 b's, so that's m to the third. Okay, so our least common multiple between these two factors over here turns out to be 90 m squared b to the third power. Okay, here is a little bit more complicated of an example. We're supposed to find the least common multiple of between x squared plus 8x plus 15, and x squared plus 6 plus x minus 6. And you're like, how in God's name do we do this? Well, it's actually not that much more difficult, okay? Here's the first polynomial. X squared plus 8x plus 15. As it stands in that form, there's nothing you can do with this. So what do you do to a quadratic almost every time you encounter one? You factor it! Yay! Okay? So, you factor it. So let's go factor this guy. As soon as I can find my pen. There we go. There we go. Okay, so what two things multiplied together give you 8 and added together give you 15? Well, we know the x and the x are here, right? Well, let's see here. If we factor 15, it's 1 and 15, you know. Or I actually said that backwards, didn't I? Multiplied together give you 15, added together give you 8. That's better. Okay, so 3 and 5. That will work. What about this guy? X squared plus x minus 6. Okay, what two things multiplied together will give you negative 6, and added together will give you a positive 1. So how about plus 3 minus 2? Okay. We do the same thing again that we've done for our previous least common multiple. Okay. We take the multiples of everything. So we have an x minus or an x plus 3 multiple here. That's a factor. Okay, we have one in each one of them, so that is good. What about the next one? An x plus 5. Well, we have at least one on the top, so that's good. The bottom one here, x plus 3, we've already got him, but what we don't have is an x minus 2. Okay, so there we go. That's an x minus 2. So our least common multiple then is the factor x plus 3 and x plus 5 and x minus 2. There we go. Okay, moving on. Oh yeah! Okay, now we come to another thing called the least common denominator. And the least common denominator is simply the least common multiple of the denominators in your expression, in your problem. Okay? Now that brings us to a key concept here, and basically it is a set of steps that you can follow in organizing your thinking about how to go about doing this. Okay, so use these following steps to add rational expressions with unlike denominators. Alright, step 1, you find the LCD. And we just determined that the LCD is the LCM of the denominators. Step 2 is change each rational expression into an equivalent expression with the LCD as the denominator. So basically you're rewriting it over the common denominator. Okay, then you add the rational expressions with like denominators. In other words, you now can add the numerators together. And then at the end, you simplify. Well, it's pretty wordy as a set of steps go, but fundamentally it is true. Alright, so let's do example 2. Okay, so it says, find this sum, a plus 1 over a plus a minus 3 over 3a. Okay. The first thing that we need to do is we need to factor a and 3a into its LCM. Okay. Well, this is pretty trivial. A factors to A, and 3A factors to 3 times A. Okay? So what's the LCM? Well, remember, we use each factor as many times as we can find it. So there's at least a 3, and there's at least an A. So our LCM is 3A. Now, since this is the denominator we want, we change that to the LCD. Is 3A. Okay? Alright. So we look at our original problem here, and the second term, a minus 3 over 3a, already has that denominator present. So we can leave that one alone, and all we need to worry about is that first term, okay? And the first term says a plus 1 over a. Now what do we need to do to this term to get the denominator into a 3a? What's it missing? Well, it's missing the 3, right? And if you multiply the bottom by the 3 here, you have to multiply the top by the 3 as well. And you have to put that in parentheses because you're multiplying the whole numerator. Okay, so you're multiplying this side by 3 over 3. Alright, and then plus a minus 3 over 3a. So this becomes, we distribute the 3 through here, and we have 3a plus 3 over 3a plus a minus 3 over 3a. Okay, now I'm doing this in excruciating step detail. Now we write the whole thing over the common denominator 3a. So you have 3a plus 3 plus a minus 3. So what's that equal? Now we combine like terms and simplify. 3a plus a gives you 4a, and plus 3 minus 3 gives you 0. So it's 4a over 3a. Well, that's bizarre. How about we get rid of the a's then? Because we can cancel. With a pen of a different color? Yeah, just like that. And we're left with 4/3. Would you believe it? That this problem, a plus 1 over a plus the quantity a minus 3 over 3a, actually equals 4/3. I don't think anyone could have predicted that looking at that original problem. Isn't math awesome? I love it! Okay. Moving on down to B. Yes, same thing. We need to add these two together. Okay? So, what's the first thing that we have to do? Oh yeah. We need to find the least common multiple between these two expressions here on the bottom. Alright, so the first one, y squared plus 4y plus 4. Well, again, we have to factor this guy, okay? Alright, so what two things multiplied together give you 4 and added together give you 4? Yeah, well, if you had to think more than about 2 seconds on this, I don't know what to tell you. Y plus 2 times y plus 2, which is equal to y plus 2 squared. And then down here, the second one, y plus 2, is conveniently y plus 2. So our lowest common multiple then is what? Yeah, what is it? It happens to be y plus 2 squared. Which means then our LCD is equal to y plus 2 squared. Okay, great. We come back to our original problem, and I'm going to rewrite it. We have y minus 2 over, we just determined that y squared plus 4y plus 4 factored into y plus 2 squared plus y minus 2 over y plus 2. So it's this second term that needs additional work to get it to the LCD state. So this side has y plus 2 and this side has y plus 2 squared. So what we have to do here then is we have to multiply top and bottom by y plus 2. And we have to do the whole thing because just like when we're doing normal fractions, y plus 2 over y plus 2 is 1. Therefore, when we multiply it, we haven't changed the truth of this expression. Okay? Because anything multiplied by 1 is still itself. Okay, so we have y minus 2 over y plus 2 squared plus, and up here we have y minus 2 times y plus 2 over y plus 2 squared. Okay. Let's go ahead and put this all over. Yeah, let's go ahead and put this all over a common denominator. So this is all going to be over y plus 2 squared. We have that first term, y minus 2, plus, now I'm just going ahead and FOIL this guy here. Okay, so we have y squared minus 4. Okay, because the inner terms cancel. Alright, well, now what do we do? Well, we combine like terms, right? And what we get is y squared, let's see, plus y minus 6 all over y plus 2 quantity squared. Okay, so this is a polynomial, a quadratic that you can factor. Alright, so what two things multiplied together give you negative 6 and added together give you positive 1. Okay, and that's your answer. Y plus 3 over y plus 3 times the quantity y minus 2 all over the quantity y plus 2 squared. Okay, this is as simplified as you can get. Okay, moving on. Alright, now we get to do subtraction. We love subtraction, don't we? Yes, we do. Alright. Now what we're talking about is subtracting. And again, you can't subtract fractions unless you have like denominators. Okay? So, let's do example 3. And again, it's on page 616, just for those of you who are dying to know. Alright, so we look at these and we need to find out what the least common multiple is for these denominators. So we have 3a minus 6. Okay, now, what can we do? You have to be able to recognize and look at that and go, we could factor something out of there, right? We could factor out a 3. If we factor out a 3 from 3a, we're left with a. And if we factor a 3 out of 6, we're left with 2. Okay, so those are the two factors there. And then we have a plus 2. Alright. Our LCM says that we take each factor as many times as it's used. So the first factor is a 3. The second factor is an a minus 2. The third factor is an a plus 2. And therefore that is also equal to our lowest common denominator. Isn't this exciting? Yes. Alright, so just like normal, we have to look at our original equation. And in this case, we'll go 4 over, and I'm going to write it in factored form, 3 times a minus 2. That's our first term. So what part of the denominator, the LCD, is it missing? It's missing the a plus 2 portion. Okay, so we put a plus 2 over a plus 2, and then subtracting. Okay, and what's the term here? We have a over a plus 2. So what is it missing? It's missing the 3 and the a minus 2 over the 3 times the a minus 2. Right? Okay. So let's kind of run all this together then. Oops. We'll put this all over its common denominator, which is 3 a minus 2 a plus 2. This first part here, we have a 4. And how about I just rewrite that, because it may be not so clear to see. Minus. When you're subtracting this quantity here, okay? So it's a times 3, which is basically just 3a, times the a minus 2. Alright, so those are the two terms that we have. And again, we'll do it again over the common denominator of 3 times a minus 2 and a plus 2. So we distribute the 4 across the inside of the parentheses here, so we're left with 4a plus 8 minus 3a times a is 3a squared, and then we have a minus here, so that would be plus, and then 3a times 2, which is 6a. Actually, that looks a lot like 69, and that's not what I want. There. So we come back down here then, and we combine like terms. We have negative 3a squared, because this is a polynomial, and you have to write it in correct descending form. So we have negative 3a squared. We have 4a plus 6a, which gives us plus 10a, and then plus 8. All over 3 times a minus 2 times a plus 2. Okay? And that, for our level of math, is the answer. Okay? And that's as far as they want you to go. They don't need you to go any further and factor the top polynomial and see if it cancels with anything on the bottom. I don't know if it does or not. I don't think it does, otherwise they would probably have you do it. So that is the final form of the answer. Okay, let's do a second one. Okay, let's do our second one here. Not in red pen, thank you. So we have our two denominators. Remember, I'm going through this, I'm showing you how to start each of these problems. And each one of them I've started by finding the lowest common multiple, least common multiple between the denominators. Okay? So we have h squared plus 4h plus 4. Can that be factored? Well, let's see. What two things multiplied together give you positive 4 and added together give you 4? Yes. So you could write that as h plus 2 squared. Alright, now we have h squared minus 4. Can that be factored? Alright, everyone should be nodding your head right now. Because of why? Because it's the difference of two squares. Remember that? H squared minus 4. What can that be factored into? Okay, well, what two things multiplied together give you -4 and added together give you 0? Because there's no middle term here. And all of you should be, right now, writing this as well as I. H plus 2, H minus 2. Okay, so our LCM then. We take each factor as many times as it's used. So H plus 2 is used twice. In other words, this factor is squared, and then we have an H minus 2. So that happens to be our LCD. Great. So now we go back to the original problem here, and we have an H minus 2 all over, and we write this one in factored form, H plus 2 squared. So what is this denominator missing? It's missing an H minus 2. Okay, and then we minus H minus 4 over, and we have an H plus 2 and an H minus 2. And what is this one missing? It's missing an H plus 2. Alright, so now we put this all over a common denominator of H plus 2 quantity squared H minus 2. And we go through and multiply these together. I'm just going to combine them right now. Okay, so that you know what we're looking at here. So we're going to FOIL this guy, and we're going to FOIL this guy. Okay, we're going to do that down here. So the first one FOILed is H squared minus 4H plus 4. Okay, minus, and I'm just going to put that in brackets, H squared minus 2H minus 8. And that's all over H squared, H plus 2 squared times H minus 2. Okay, now we combine like terms. And that's all going to be over H plus 2 squared times H minus 2. Okay, so H squared minus H squared is 0. You have a negative 4H minus a negative 2H. Okay, so that gives you negative 2H. And then you have a plus 4 minus a minus 8. So that gives you plus 12. Okay. So negative 2H plus 12. Or you can factor the top here into negative 2 times H minus 6 all over H plus 2 squared H minus 2. Okay, either one of these is perfectly acceptable for the answer. Okay. And that's as far as you need to go with it. Okay. All right. Thank you for watching the video to the end. This is Golf Ball Head. And I know you all love Golf Ball Head. Yes, everybody loves me. Yes. Uh-huh. Oh yeah. Uh-huh. Oh yeah. Yeah. Sorry, got a little carried away there. So back to the point. Thank you for watching the video to the end. This is, awful looking math. And if I had sat you down at the beginning of the year and said, here, do this, your little brains would have flipped over. Several of your convolutions inside your head would have unraveled. And then I would have had a lot of explaining to do to all your parents. But as it is, you can do this because we have brought you to this point and shown you how to do it. So, good luck, If you have any questions, be sure to email me and I will be there for you. Don't forget about my math help every day, 3 o'clock to 3:30. All right? Okay. Bye.